Okay, it's also known as the ZYX notation. So we'll always use psi for y, sorry, for z. We'll use theta for y and phi for x. So just we are consistent. So what 3-to-1 does is we first rotation by psi about the z-axis, theta about the y-axis, and then phi about the x-axis. So let's just draw x, y, z. First rotation is, okay, so you always look at it from the positive z-axis you're trying to rotate. And then we rotate about the z-axis. So when you rotate about the z-axis, what will happen is the y will move to y prime and x will move to x prime. And this angle is psi. Okay, next we'll rotate by theta about the y-axis. So when I say y-axis, I mean the new y. It will be y prime. So let me draw the new configuration: y, x, z. Note that this is y prime, this is x prime. So now I rotate by theta about y-axis. So again, you look at it from here, theta about the y-axis. Okay, so this is really hard to draw. So you have to imagine the zx plane, the rotation happens in zx plane. So the z would move here. Let's call that z double prime because now we are in second rotation. And then x will move like this. And this angle turned is theta. Okay, we have one more rotation to go. So now let's rotate about the x-axis. That will be x, the new x-axis. So it will be x double prime. So I'll first draw the new x, y, z. The new x, y, z is x. This is y, z. So this, sorry, z is this way. It should be the z double. So y is y dash and then x dash. No. Sorry, my bad. This should be x double dash. This should be z double dash. And then y. Okay. Now let's turn by phi about the y-axis. So again, x-axis. So look at it from the positive x-axis. Rotate by an angle of phi. And so this rotation will pretty much move everything in the z-y plane. So the y would be y triple prime, and then z would be z triple prime, and then this would be phi, phi. We'll do this today. Okay, so let's assume that there's a vector C0 which goes transformation to C1 because of the first rotation. Then we have a vector C1, which is this one starting off from where we left to C2. And then here, finally, we go from C2 to C3. The reason I wrote the C's was that I'm trying to relate what happens to a vector when I go from C0 all the way to C3. So between C0 and C1, you see 0 be R Z psi C1, then C1 is RY, that is theta C2, C2 is RX, P C3. Okay, so why is this so? I mean, this you might want to relate this with what we had done in the past. If you remember, it was we had x0, this is a different color. So if you remember, we had x0, y0, and then x1, and then we had theta, and then we said that if you take R and you multiply with the vector x1, you get, or any vector in frame one, let's call it C1, you get C0, right? I followed the same logic here. The same formula is over here, essentially the same. This is for 2D. But here, I'm just extending it to 3D one at a time. So all these rotations are similar to 2D rotations because they're about one axis. And so I can repeatedly apply this formula. And then if I now eliminate okay, so if I eliminate C's, the intermediate C's, I can write C0 equals RZ, RY, RX, C3. Okay, let me write it on the new page. So we have C0 is RZ psi, RY theta, RX phi, C3. Okay, or C0 is R times C3, where this is in fixed frame, right? This is the global frame, world frame. And this C3 is in what is known as a body frame. And this rotation matrix is the matrix which tells me how to combine these three individual rotations in order to get the combination or the final orientation. So the formula which we were really after was that the position in world frame is R times R in body frame. Position in world frame position in body frame. R is the rotation matrix. Okay, so what is R? Well, it is those three multiplications, right? So I'm just going to write a formula for R. It is R Z psi RY theta RX P. It comes out to be something like this. I'm just going to put it down, but you will, in principle, you will never really write it down because you normally use a symbolic package to compute R. Okay. So it's only one last time I'll do it because it's not very interesting. Cos C, cos psi, cos theta, sine psi minus sine theta. That will be the first column. The second column is cos psi sine phi sine theta cos phi cos psi, sorry, sine psi cos psi cos phi plus sine phi sine psi sine theta cos theta sine phi. Just in a room. Okay, that's working. Okay, last column. Sine phi sine psi plus cos phi cos, my God, cos phi, write it up, cosine psi sine of phi sine of theta cos phi sine psi sine theta minus cos psi sine phi. Okay, I'll just highlight this just so that's one quantity. And then we have cosine phi cosine theta. This is one. And then this is one. Okay, so, well, you, as I said, you will not never really write it. So I'll just wrote code, which really does it for you, symbolic code. Essentially takes the rotation. I just wrote Rx, Ry, Rz, and it basically computes R as the multiplication of Rz times R10, which is R by Rx, so Rz, Ry, Rx. And if you use the symbolic toolbox, it will basically give you the formula, which I basically took it and it copied down there. Okay, so this code does something more than that. It takes a box like the one I showed you and does 3 rotations. So run this. So this is just showing 3 rotations. So you start with same object as earlier, 0, 0, 0, rotate by 90 degrees about the so rotate by 90 degrees about the z axis, so blue. So the blue remains unchanged, the axis. Then we have 90 degrees about the new y axis. So remember the y axis are always green. You can see that the green is unchanged. And then finally we have rotation by 90 degrees about the x axis. So x is red, so you can see the red is unchanged. And so this is how it ends up with. And so you can use this